Math Genie, where are you? I think we have a question we can model. I'm so excited.
Amazing. Tell me more.
The students are really interested in women in STEM. They want to know more about the impacts of increased representation. We have some data, lots of data actually, but I'm not really sure where to start.
Ooh, first, make sure you have enough data to begin a conversation, but not too much data that is difficult to work with. Sometimes too much data is not a good thing either, especially when our students do not have much experience with mathematical modeling. It can become hard to model and too complex for the stage where our students are. You know what? One of the members of the audience just texted me asking about the research process.
The members of the audience?
So let's backtrack a little bit. Here are some things to keep in mind when gathering data. Students often need to learn more about their research topic, and through research, they realize that some of what they think about the topic is not actually based on data. Researchers definitely needed to figure out exactly what elements, boxes or compartments, to include in the model, and what elements to drop. Data collection is a demanding phase because sometimes students have to spend time searching through numerous references, documents, and so forth. Judge what might be relevant for the model. This includes the challenging task of connecting various pieces together. For example, they need to ask, is it really true that A causes B? And maybe it's just a correlation. This data shows that both X, Y, and Z affect W, and not just X. Does this make sense?
Yes, I
was asking the audience. Let's go back to what to do once the data is collected. Framing and scaffolding happen during the phase 2. Framing and scaffolding happen all the time in education.
What do you mean?
By this stage, students have understood why some questions they initially asked were not answerable using mathematics and coding, which is a really good learning experience. Now, you can start to have conversations related to the limitations of mathematical modeling and coding. This helps the students to think about what the math code can do for us.
I like that idea. Students don't always get to learn about the limitations and affordances of what they are learning. I like the idea of introducing that into my class.
Yes, and revisiting and discussing the data also helps students to think about which data would be most suitable for answering or modeling different issues. It's really a cyclic process, which results in fine-tuning of the research questions, modifications of the fuzzy maps, and the corresponding code. For instance, students had to realize that data comes with units, and that their map had to be adjusted based on dimensional analysis.
Interesting.
Aha! Here, some professors share their strategies about doing the fuzzy maps with students.
When we did this project, we revisited the data with the students and guided them toward which data would be most suitable for answering or modeling an issue.
Yes, we did the same thing. We guided the students because they did not have experience modeling before, and choosing data can be tricky.
Us too, but we used a more direct approach. Several times, students were given a task to figure out the specific number that was needed to complete their fuzzy map.
Yeah, and sometimes those numbers had to be estimated or approximated, and then that caused us to reevaluate the numbers, and then students needed to modify the code to reflect the reevaluation in the fuzzy map.
But once the code ran, that's when I really needed to support learning in my students.
I know what you mean. In some cases, the outcome was judged to be disproportional, for example, out of the expected range. That required that students revisit their data sources, check for accuracy, and modify certain numeric values in the fuzzy map.
That was really interesting when that happened in class. It caused a lot of new learning experiences.
Yeah, I know. Listen to this story. In a discussion with students, we touched upon challenges in modeling that go beyond those imposed by the data or coding. For instance, a more complicated model is not necessarily a better model, and the art of modeling often revolves around including the right elements. This also means that not all data that students identified could be or should be used.
Oh wow, that is a really awesome lesson.
I know.
We completely have to do this in my class.
Who was that?
It was me.
How did you get in there?
You're asking me how I got in there? When you appeared out of thin air?
Oh, okay. We are digressing.
So is that it?
No, wait. The interventions.
The interventions are one of the most important parts. Students can be really interested in how to make change. I'm going to love this part. So how do you introduce the interventions?
The students go over interventions and decide on the range of values that the interventions could have, which either increased or decreased their role in the model outcomes. This gave the dynamic structure to the model. For instance, seeing how the outcomes changed based on the incremental changes in interventions. It was really cool to watch the students' faces as their model visualized for them how they can support change.
Awesome. Can you tell me about the code?
What am I? A math genie that answers every question you ask and gives you all your wishes?